So, Agile and Lean software development, that's what I've been asked to talk about today. There is, of course, a whole separate course on Agile and Lean software development. I think most of you are already taking it, but I hope that I'm able to give you some additional perspectives on that course in this lecture. So the idea is today we talk about a bit about the background of Agile and Lean and so on, current research trends, where is the Agile and Lean community moving towards in terms of research and so on. And then I'm going to quickly switch into talking about what is value in software engineering, value in software development, because that will be a nice segue into lean development. And lean development and DevOps and so on is interesting because, well, of the DevOps aspect of it. So that's the idea of today. Starting with a background. Software engineering projects tended to be, before Agile came along, rather long-winded operations. One iteration might take 2 years from when you get your initial requirements all the way down to you actually have tested and deployed it and then doing maintenance on it. Because these were so long-winded projects and long-term projects, you had larger requirements on having more of a line organization around it. You would have management would be a separate thing, which would focus mostly on just staff issues and management of the products and everything. You would have people who do traditional requirements engineering. You would have developers who would do mostly only development, and then you would have testers, and then deployment would be a separate unit, and writing user manuals and so on, and you would do maintenance somewhere else completely. So you would have very clear roles, and there would be a large, or would often be quite a separation between these roles, which in some ways meant that you could focus on doing one thing and doing that well, but it also meant that you had a lot of issues that were should have gone across roles were left out. You would have process steps connected to the roles. So you would do the requirements roles. The people working with requirements would, of course, just do requirements engineering. That's one step of the process. And once they are done, they will throw over everything they've done in terms of requirements engineering over to the developers, and they would do development. I mentioned Conway's law here. Conway's law basically says that if you have an organization and a software system which is developed by that organization, eventually the architecture of the software system is going to start looking like your organization. So if you have one organizational unit working on a particular sub-area component, if you will, knowledge area, and if you have need for that in your architecture, that component in the architecture is going to mimic and be developed by that particular organizational unit. If you have something else, say user interface, that's another component, and you would have an architectural component working only with the user interface. You would have a mapping between your software architecture and your company organization. And vice versa. If you have a particular component in the architecture, eventually you're going to have an organizational unit who is mostly responsible for dealing with that particular component in the architecture. So it's not a causal relationship that you have an organization and you get an architecture, or that you have an architecture and then you get an organization. It's rather a rubber band effect that you move in both. If you add an organizational unit, well, there's going to be eventually architectural components mimicking this, and if you do something in the architecture, it's eventually going to be reflected in your organization. What this means in practice is, well, apart from all the good things that you actually can focus on your knowledge area, it also means that if there are things that should have been done by many, it's not done by anyone. things tend to fall between the cracks. People can always say, well, this piece of functionality or this quality attributes in particular would fall between the cracks here. We can't fix it inside our module. We can't fix it inside our organizational unit. It must be someone else's problem. And because it's someone else's problem, it's going to be pushed to someone else higher up in your organizational hierarchies, and you might not find a place where it actually fits. So you end up saying that, well, these quality attributes, it's everyone's responsibility, and that means simply that it's someone else's responsibility. It's no one's responsibility. Um, so Conway's law started out as just an observation. Sometimes it's a good thing, and oftentimes it means that you need to think harder when you organize your processes and so on, so that you don't let things fall between the cracks. And if you have these clear separations of roles, these are of course orthogonal to the software architecture. You have similar risks of things falling between the cracks, that you would do one particular role deals with one process, and if it's not part of that process, well, it's not being done by them at least. As a counter reaction to these plan-driven software projects where everyone else was at fault, but no one really took responsibility for the end result, you started having these grassroots movements that we need a revolution in terms of how we develop software. And Agile was one of the more successful. It captured a number of good qualities for how we should think when we develop software. There are a couple of values there in Agile. So for example, that they focus on, or we value individuals and interactions between individuals more than having a well-documented process and tools that will help us along, which was the old plan-driven idea that if you have a process and you follow that process, you will get a predictable result. Well, that predictable result is only valid for that one particular software component or software system that you're building. If we instead focus on how to get individuals working and working together, we can have an environment in which we can develop software over and over again. Focus more on working software rather than documenting it perfectly. Documentation, again, if you have these long projects, you need to document so that you can remember 2 years down the line, you can remember, why did we do it like this? And you plan things and you do design documentation and you do all sorts of different documentations because, well, the process step we're in now says that we should document our design. So we can't leave this process step until we've documented the design. Whereas the agile way of looking at things is rather that, well, we can get stuck in this process step forever, documenting what we're supposed to do, but we'll never get to the point where we're actually developing something. So let's focus on getting the software to work first, because the moment we have something that works, we can start earning money from it and we can get feedback on what we should have done. Again, we have something we can show for our individuals, our customers, if you will. We can interact with them, and then we can build something more together. We can collaborate with the customer. And see it as this is a joint effort. You as a customer, you want something, we as developers can deliver that if we work together. It's not a matter of that we get the perfect requirements documented again, and we get the most perfect contract and we can go our separate ways, and then let's meet each other 2 years down the line and we'll deliver something exactly according to the contract, which is going to be obsolete and full of imperfections anyway. Let's collaborate instead. We both want the same thing. We want you as customers to be able to leave us happily with working software so that you'll come back and we can continue working with more software. Rather than having these well-documented plans, any general in in wartime will tell you that plans never survive contact with reality. So you might have a basic idea of where you're heading, but it's more important that you're able to respond to change, that you're able to pick up when the customers say that, well, this isn't really what we wanted, or our competitors are now doing this. Can you help us with that as well? So it's more important that we keep adjusting to these changes, so that we in the end can actually show that we're able to deliver something that is up to date with what the current needs are, rather than relying on a plan that's outdated and well documented, but it's still outdated. So these agile values are at the core of every process that calls themselves agile, in some sense, that these are the things that you focus on getting right somehow. And then there are different ways of doing this. Incidentally, if anyone has ever read Che Guevara's book on guerrilla warfare, you'll notice that these values are true for that one as well. And as a counterpoint, guerrilla warfare compared to the old plan-driven army-style warfare, you'll notice that there are quite a lot of similarities there. Scrum, which I believe most of you have heard of, you are probably working with it in the Agile and Lean Software Development course, is one of the more predominant Agile frameworks today. It's not the only Agile method. I guess, knowing Torbjörn, that he has introduced a bunch of others. And the point is, there are a lot of similarities between them, and there are some minute differences and some things that set them apart. They all ascribe to the same basic principles. These agile values. So you, as I said, with these values, you can do things differently and still stay true to these values. And these different approaches do things in a slightly different way, all of them. So I won't talk more about Scrum, because you have this whole separate course where you are talking about Scrum. Lean is something you often hear people talk about Agile and Lean as if it's one word. So you often bundle them together. They're not the same thing. They do have somewhat the same goals, but whereas Agile is focused on, well, as the name implies, responding to change, being nimble and on your toes, and being able to quickly react to a changing reality, changing requirements, and so on. Lean is, the end result is the same, but they achieve it in a different way. Rather than just focusing in on being agile and so on, Lean says, well, don't do stuff that's not necessary, because that's going to be a baggage that you need to carry around afterwards. You need to maintain it, you need to take care of it, you need to consider it when you're trying to build new things. You need to consider everything that's there. So don't do things that aren't necessary. And part of that is wait until you know you actually need it. We can have this idea that we need to do all of these fancy things somewhere in the future, but let's not do them now, because then we have this baggage that we need to carry around until we need it. So wait until you absolutely need something, and then make sure that you have it available. Two tools that you often see in Lean is value stream mapping and Kanban. I'll say a few words of each of them. Value stream mapping is basically the idea that you go through a process flow, and you identify what is a waste, what is something that you're doing that isn't valuable, that doesn't lead to anything meaningful for the customers. So this is originally from the manufacturing industry. I think, I'm guessing Toyota was an early advocate of value stream mapping. So a lot of the things that you do when you do it in the manufacturing industry make sense there, but you need to translate it into something meaningful when you do software engineering work. You would typically, in a manufacturing situation, you would walk the process backwards. So you would look at each, you would have the assembly line, and you would start at the end, and you would look at, what are you doing here? Well, we're adding this. Okay. Do you have everything you need in order to add this? Yeah, sure. Where does it go from here? Yeah, it goes there and there. How long are you spending on this? Are you waiting for anything? Are you doing something that you shouldn't be doing? Are you transporting it somewhere and so on inside this process step? And where did it come from um, until to this point? Well, it came from over there. Well, why is that station closer to this one if you're working so closely together? So do we have any transportation between us? You walk this process backwards, and you do it backwards simply because it's easy to look at each process step in its own right. If you start from the beginning, it's like a story. You can more or less fill in the blanks because you know where the story is headed. Walking backwards means that everything can be looked at uniquely. Um, Another way of doing it is that you look at one particular item. An item enters the assembly line, and then you follow that item uh, all the way from where where it enters the assembly line to where it's assembled and shipped. And you can see what is done to this one item throughout this entire process. Um, and you look for these things. You look for when you're waiting for things, how many defective items are there in there, and so on. And all of these things you look for. Um, and when you do software engineering and software development work, you can look at things in the same way. You can look at, are you doing things that are partially performed and then scrapped? So one thing that happens in a software project over time is that things get uh, uh, put into scope of the project and then descoped. And that might happen back and forth as you respond to change. You plan that these are things that we should be doing now, and then eventually you realize that, well, we might not have time for it, or the focus of that release changes, so let's descope things, let's wait with them until the next release, and then eventually you'll in-scope it again, and you might descope it again, and so on. And if it's just a planning point that you have a requirement that's added to the project and then removed from the project and added to the project, that's one thing. But if it is something that you've started working on, it's scheduled and you have people working on it, and then halfway through you realize that, yeah, no, sorry, we're not going to do this for this release. Then of course it gets more expensive. So you do partially performed work for whatever reasons. Um, you add things that shouldn't be there, extra features, gold plating in requirements engineering. You do things with uh, your development efforts that is just extra. It doesn't add anything. You document things when it doesn't need to be documented. You add all of these fancy Java doc comments, for example, to your code, whereas if you'd written the code better, you wouldn't need them, for example. Uh, and then once you've built a function, you need to deliver it to someone for inspection, and that inspection might be handing it over to someone else for correction, and eventually you might get it back. And all of these handovers means that you're transporting the code, and you're transporting context. For every time someone has to look at the code, they have to figure out the context for this code, have to figure out what does this code do, what is its intentional side effects, what are its unintentional side effects, and so on. So every time someone looks at the code, someone new looks at the code, it's not just these 5 lines of code, it's everything around it as well. So reducing the number of times you have to do that means that you can focus on actually delivering something instead of just figuring out what did we do. Switching between tasks, if you are one developer and you work on more than one thing at a time, then you're doing a little here and then you're doing a little here, and that's the same thing there, that you're doing a lot of context building. You figure out, what am I doing here, what am I supposed to be doing here, and then you switch to something else, and then what am I supposed to do here. So having a smaller set of tasks to work on is usually uh, more productive because you can focus on one thing and you can figure out how should I do this best before you move on to, so finish that task before you move on to the next one. Delays, well, I can't do anything because I'm waiting for well, the manager to sign off, or I'm waiting for this other team to build me this other component that I need to use or whatever, or I can't use the test harness because it's in someone else is using it, and so on. And defects are, of course, self-explanatory. So these are things that we can look for in our development projects, and we can figure out, do we have them? What effect do they have on what we're building? And how can we do things in a different way such that we avoid some of these wastes? Kanban is, well, it's actually a whole development process in its own very simple description. It doesn't go into detail about roles or anything like that. It basically says that you have a backlog of things to work on, and when you are free as a developer, as an individual, you pick one thing from the backlog, the first thing, and then you pull it through the entire workflow. And once you're done with that, you go back to the backlog and you pick the next item, and you work with that one. And the idea is that rather than having these planned events, let's all gather together and let's figure out what we should be doing for the next 3 weeks or whatever. And then we build upon that, and then we release that, and then we synchronize so everyone is finished at the same time. And then we go back and we pick a new batch of things to work on, and so on. Even though with a 3-week sprint in Scrum, it's a lot less planning, it's still a lot of planning. Whereas in a Kanban, well, you have the backlog. If you're free, go and take a new item. Make sure that you fix it. And if priorities change, even if it is, so in Scrum, the 3-week iterations, it's still 3 weeks that you could be working on the wrong thing. If you have a rapidly changing environment, if you have rapidly changing um, requirements or whatever, then it's still 3 weeks that you're working on the wrong thing. So with Kanban, you basically, if reality changes, well, you can always throw away the backlog, add a new reprioritized backlog with what the current reality is. And as soon as someone is finished with whatever they're working on, they're going to start working on these new priorities. So you can always change immediately the priorities. I'm not sure it's good in the long run to do this for all types of projects, but you at least have the option. There are 3 core pillars to Kanban. One of them is to visualize the workflow. I'm going to switch back and forth between these 2 slides now. So you will often see what's called a Kanban board. Can be a whiteboard, can be a pin board, can be online somewhere. If you've worked with Trello, for example, it's a simple way of doing a Kanban board. The idea is that everyone should see what's the current state of the project. We have a backlog when we have things moving from the backlog to the other end where they are deployed and live. That's one thing we can see as a manager. You can go, you can walk by, you can see that, well, there's a flow, things are happening, things are moving from here to here. If you look at things over a day, you can see that things are moving from one end to the other. That's one thing. The other thing is to limit work in progress. And that is you intentionally introduce bottlenecks into the process. So here, for example, you can only have one story in the deploy column. You can have 3 stories in the development column, and you can have 2 in the selected column. What this means is that if you as a developer, you pick an item from the backlog and you start working, you finish the selected phase, you develop it, you're ongoing, and you're done. and you try to deploy it, and you realize that there's one story here which is already trying to be deployed. Then you can't deploy your story until this is resolved. So you leave your story, get over to the story that apparently something is holding this one up. It's not as easy to deploy as it should be. So now there are two of you working together to solve this bottleneck. You solve this problem that is preventing this story from being deployed. Eventually, the next guy is going to come along. Next person is coming along and realizing that, well, I can't deploy my story because, well, this story is still stuck. So now there are three of you. So you pool the resources. Automatically, resources get pooled to the area where you need them to be in order to get things out. So you focus on the flow all the time. So the stories should flow from the backlog and to the other end of the board. And if something is holding up the flow, well, eventually the resources are going to be pooled there so that you can resolve this, unplug whatever is sticking and causing things to not be able to move forward. And then you again get the flow going. So once this is finished, once this is deployed, well, those of you who had stories that were in the previous phase, you go back to those and you'll push one of them into the deploy phase, and the person who was responsible for this story can now move it over to the live phase, and then when they are done with this, they can go back and pick the next item. So you always have this flow through the Kanban board. So that's why you intentionally limit the work in progress items in some of the key columns in the Kanban board. The last one is that you measure lead time. It's simply that you try to keep track of your velocity. Individually, as a team, or as on the stories itself, all of these things is interesting for you to know. What's your velocity as an individual? What's your average velocity as a team? What's the velocity of backlog items of this particular size and type and so on, so that you can start planning. When you see things in the backlog, that means that you have you build up a tool based on your experience, based on your project's abilities or your team's abilities, you're able to communicate with the customers about the items in the backlog. How long until we get to this point where we can take this item down here in the backlog? Well, based on our velocity as a team, based on the stories that lie ahead of you, well, we might get to it within so and so many days or whatever. So measure your lead time. Research trends. Well, it's basically all over the place if you look at the Agile and Lean research communities. Some research is in looking at the business side. Let's see, someone is raising their hand. Would you like to ask a question?
Yes, please.
Sure.
I got a question about the previous slide, if you mind. Yeah, this one. And about the bottlenecks. Who is responsible for keep the team balance? It's a role of Scrum Master.
This is Kanban, so this is not Scrum. So you don't have you don't have that kind of team master like that. You're working as an individual on a user story.
Okay, so
go ahead.
Also, there is no daily meeting, yeah?
I would say that there's nothing. Kanban doesn't say that you must not have meetings. What Kanban says is that you should visualize the flow, you should limit the work in progress, and you should measure your lead time. So you could, and you often do, use Kanban together with a Scrum team. And that's perfectly okay.
Yeah, so the individuals, the team members should keep balance between themselves. Yeah.
So the balance happens because, well, you work on your story, and some stories go faster than others. So some people will be coming back sooner to pick up a new item from the backlog and push that through. And the moment you have something that stops the flow, resources will automatically get pooled there. It's not someone, no one has to go in and say, oh, we need to solve this issue now. Because simply because you have limited the work in progress, you cannot push your story forwards until you resolve that issue. So it's self-organizing in that sense.
Yeah. Okay. Thank you. I got it. Thank you.
Right. So in product line engineering, they talk about these 4 different things that you can focus on. They call it the BAPO model: business, architecture, process, and organization. And when you look at the research in Agile and Lean, you realize that, well, it sort of follows more or less the same trends. Some of them focus on how can we work on the business side of Agile and Lean, how can we work together with the customers, how can we get better requirements, better customer interactions, and so on. Some of them focus on what architectures are better at supporting lean development. So how can we work with larger projects? How can we organize our system and our infrastructure such that we can work with larger software systems using lean and agile methodologies? Some of them focus on the processes. How can we scale up agile, for example? How can we do having several scrum teams working individually or separate teams, but working on the same product, and then synchronizing the work between them, for example. An organization is process and organization are, of course, as always, go hand in hand in some way. That how can we scale these things up? So looking at a couple of different workshops, and I took one of the big agile conferences, XP, and I just did a word cloud looking at the titles and topics of all the different publications in that area. What I saw was, well, technical depth was big. This is something that you have to deal with. It's basically when you add things to a project, when you add things to a product, you basically you can do it right, or you can do it as quickly as is necessary to solve the issue at hand. And when you do things that sort of breaks the architecture, or at least bends the rules of the architecture a bit, what you're doing is that you're creating a maintenance effort for you in the future. You're creating a depth to yourself, a technical depth to that you will eventually have to go back and fix. So technical depth was big then, and I don't see that changing. It's still something that is very important. It's also a matter of when you add features to the product, these features can start out as being uh, customer adaptations for one particular customer. Then it might grow to be something that more customers want. And eventually it might be superseded by something else, but you still have this piece of code that you need to maintain unless you're able to absolutely keep track of who are the customers that are using this piece of code. And the moment you put things into the main product, well, it's there, and so if it's individual customers and they are paying for it, then you obviously keep track of it. But the moment you say that this is a common feature, this is something that is just inside of the basic offering that this product has, then you stop tracking who is actually using it, so you don't know when it's no longer in use. And that is something which is also a big problem to figure out these things. And that's the technical depth for you. You're maintaining something, but you don't even know if it's being used anymore. Internet of Things, well, it's a buzzword. What can I say? It buzzes up everywhere. I'm not sure what it has to do with Agile and Lean, but people do look at it. Large-scale agile, that's the organization and process part of it. How can we scale things up so we can build bigger systems with more teams, more diverse teams, and more geographically dispersed teams? Um, so there's a lot of research on that, and you see a lot of new frameworks that pop up to try to address things. That how can we organize ourselves so that we can develop larger systems using agile. Safety critical showed up as well, uh, simply because the focus on working software and let's wait with the documentation, only document what we need and so on. This whole streamlined, lightweight approach to things means that many quality attributes tend to be neglected a bit. If you involve the customers in negotiating the backlog, you will have probably more focus on new features in the backlog, uh, whereas it's harder to explain to the customers why safety, for example, should be a separate item in the backlog. It has to be, otherwise you won't have the resources enough to work in a meaningful way with it. But you need to convince the customers then that this quality attribute safety should be an item in its own right in the backlog. And the customers will always ask, well, aren't you building safe software anyway? What's wrong with the software that when I ask for this feature, whatever it is, of course I expect it to be safe. Are you building a software substandard just to uh, trick me into adding new stuff to the backlog so I'll be paying you for longer? What's going on here? So it's quality attributes in general. Safety is, of course, more important because people might die if you get it wrong. Um, uh, is something that you need to look at in terms of the processes, in terms of the architecture, in terms of how you interact with the customers, such that you actually get support for building more safety critical software with Agile. But one key point here is that there was a lot of research about the individual practices. What's the effect of using test-driven development on code quality, for example? What's the effect of pair programming on maintainability of the code, organizational memory, and so on? You can look at each of these individual practices from, for example, extreme programming, and you can see, you can measure all sorts of things there. That is sort of done already. I wouldn't say that it's finished, but people have more or less gotten bored with it, which often happens in research communities. So now what we're looking at is the whole methods, trying to figure out not the individual practices because they have been researched, but how do they fit together as a whole method, and what's the effect of using lean software development or XP or Scrum on whatever qualities that you're looking at. And also then how can you scale them up? How can you make them more safety critical? How can you make the whole method focus more on quality attributes or whatever? It's no longer the individual team, one scrum or whatever, measuring their velocity, measuring their performance and so on. It's more about how can we as an organization figure out what's going on? How can we control this as an organization? And I guess that's kind of expected. When you started with Agile, as I said, this started out as very much a grassroots movement. People started doing Agile inside the projects as sort of a guerrilla movement because it meant that they could do more software faster, focus on these self-organizing teams and everything. Everything was fun and you could do things. And of course, the management was sitting there and wondering what the hell is going on. People are doing things, but we have no way to control it. We have no way of understanding it because they're just doing things. Same, I mentioned Che Guevara, same thing there, that the guerrilla warfare is excellent for doing clandestine operations, and XP and Scrum started out as clandestine operations inside companies, getting things done that needed to be done, but under the radar of the management. And now now that management has caught on, they are looking for ways of understanding what is going on, how can we control this, how can we use this to get people to be more productive, uh, somewhat to the extreme where you actually can have tabs, much more tabs on people in an agile development project than what you ever had in the old plan-driven days. So you're probably going to see in a few years. That's not an industry trend that's being researched, but my prediction is that you're going to see more people being burnt out simply because you have much more control over what you do with your time, how that you're constantly being productive. And if you're not, well, you have all of management bearing down your neck, breathing down your neck, trying to figure out why aren't you productive anymore, and so on. So we're moving from the individuals to organizational understanding, and organizational understanding is both understanding project as at large, but also from the management side, try to understand what is going on at the smallest level. We are moving. So initially you would talk about 30-day sprints, and then it was 3 weeks, and then it was 3-day sprints, and today we're talking about continuous development. So we're moving more and more into the lean side, where you have you're releasing things all the time, you're deploying things all the time. And how does that work? And the focus has always been with Agile and Lean to focus on delivering value to the customers. We're not just doing development. We're not going to lock ourselves up for 2 years and do development and follow this development process and so on. We're going to build things because it's fun. We are always looking at how does this add value to our customers. Sustainable agile development is also you could summarize many of the previous things I've said into sustainability, because it's about how do we do scalable development, how do we make sure that we are able to continue doing this, and that includes also the workforce. Everything I said just now about um, burnouts and so on, how can you avoid that? How can you make sure that people have time to reflect and recuperate between projects and so on, and between iterations, so that you have a sustainable workforce? You don't need to throw them out and get new people all the time. How can we automate things like testing? If we're doing continuous deployment, we want to be able to automate our testing so that we know that when we deploy something new, we don't break everything that we used to have working. And management of technical depth is very important for us to become sustainable, because the more technical depth we have, the harder it's going to be for us to add new features and develop new things to the project, because, well, it drags you down. It's like clay sticking to your feet. You get heavier and heavier and heavier, and eventually you can't move just because of all the technical depth. So how to manage that, how to keep it at a manageable level, is something which is very important for us to be able to continue working with an agile project or an agile developed product. So it's very much about sustainable development. Let's take a break here. I'm going to pause the recording. So value. Since I've talked about that, Agile and Lean focus very much on delivering value to the customers and value to all the stakeholders involved in the process when they are suitably prioritized. So what is value then? So a colleague of mine, many years ago now, wrote an article about variables that measure success in requirements engineering, but it's actually rather useful as a discussion tool to talk about value as well. So his idea was that if you look at the requirements phase, you have success criteria that are um, when have you done a really good job in terms of requirements engineering? Well, it's when you have all the requirements, you have talked to all the stakeholders, you've identified and talked to all the stakeholders, and you have all the requirements, and you have them well specified, and you have everything pat. Everything is, you know exactly what everyone wants of the system. You've prioritized it, you've negotiated it, and everything. So all of these things are quality indicators of a good requirements engineering process. Now, if we move out to the project level, what does that mean? What that means is that you will not be able to keep, for example, any deadlines for the project. You will need to have more resources in the project. You need to have a lot more people in order to do a good requirements engineering phase. So when you look at the project level, you are going to make conscious trade-offs when you so inside the project, when you decide how much time should we spend on the requirements engineering phase, how much time, how many people should we have working on the requirements engineering phase, and so on. You're going to make trade-offs because you have project criterion, success criterion, that are more relevant on that level, obviously. And that means that when you optimize on the project level, you will make trade-offs on the requirements level. And when you optimize on the requirements engineering level, you are going to make trade-offs on the project level. So what's the success criteria for a project then? Well, it's that you deliver on time and you deliver on budget. And that means that you use the appropriate resources when you have them available and so on. And that's about it for the project, really. On time and on budget. What you deliver is not really that interesting from the project level, mind you. So when you measure what is a successful project, you look at, well, how much time did it take? How many resources did you need? How many people did you need during this project? And that doesn't really matter for what you deliver, as long as you've delivered something, that you've delivered according to what was planned. That was also is also part of the project. So again, moving out to the product then. The product, well, if you have this killer feature, whatever that may be, it doesn't really matter from the product side if your project runs late for a week or two, if you're able to deliver this killer feature. So when you decide what's best for the product, you may need to sacrifice things on the project level. You realize that, well, if we cannot deliver this feature on time, so we need to extend the project. We need to break the project in some sense, the plan for the project, in order to do what's best for the product. And so on. If we move on to the next level again, we might realize that for one particular product, it might be great for us. Let's say it's great for this product to have this wonderful feature. Let's call it feature X. The only problem is that that feature X is also something which is a key selling point for our other products, our flagship products. They are feature X compliant, and that's what makes them our flagship products. So on the company level, we need to decide that, well, not everyone can support feature X, even though it would be great for this other product here, this low-level product here, but we are going to focus on only our flagship products having this feature X. And that's for the company to decide that what's good for one product is not necessarily good for another product. And we need to balance that. And then companies need to exist in a society, and what's good for one company is not necessarily good for the society. For example, let's put all our chemically intensive development into a few towns in India somewhere, and we don't really care if they have lakes that catch fire ever so often, because, well, it's not the company's problem, but it is the society's problem. So we need to make sure that our companies can fit into a society and play within the rules that society sets upon us. And I would say that a very basic requirement is that companies should not set lakes on fire, but that's another story. So to answer the question that came up during the break, it is very much what you can measure in terms of what is valuable. It depends very much on the focus that you have. I think that if we look here, so business value is, of course, one thing, that this is something that the customers are willing to pay for. The customers want this, the customers have prioritized this, and so it's the top of the backlog. For whatever reason that our customers do that, but they have explicitly said that this is the most important thing that you can work on right now. That's what delivers most value to them. And that might not be, that's not always developing a new feature. It could be that they say that the most important thing right now is that you document, you write a user manual, for example. It could be that they say that, well, the most important thing right now is that you refactor the code, work with the architecture such that you're able to deliver these other features much more quickly in the future. That could be something that is highly prioritized by the customers. Probably it's something that we will have to nudge them into understanding that, well, working on the architecture is an investment for the future. But it's still something that we can do, and it's still something that, well, it is a business value that we do this architectural work now such that we can quickly come up with new features in the future. Lean, well, what is, they have a different take on it. So Agile basically says whatever the customer prioritizes, that's it. Lean says that if we remove everything that costs things but doesn't add anything, so if we remove waste, and if we remove things that are costly and waste, whatever remains must be of value. So it's a Sherlock Holmes version of looking at what is value. If we remove everything that's not value, well, whatever is there has to be the value. Value stream mapping, as I mentioned, is one tool to figure out these 7 wastes, seven types of wastes, is one indication that these are things that if we kill them, if we remove them, if we do something about these things, well, whatever we have left is obviously valuable. So value stream mapping is one important tool to figure that out. Just-in-time production, that we don't create a lot of code, a lot of produced materials that are not going to be used. So we try to produce it just before it's needed. That is in terms of code, but it's also in terms of information for the code. So if I need to have a particular decision in order to be able to build something, well, there's no point in getting that decision and then 2 years later I'm at the point where I need to build the code. Let's push that forward. So I have the decision as late as possible, but have it ready when I need to start working on the code. Looking at how can I use things for more than one purpose is also a way to look at reducing costs, really. So if I, for example, write my requirements as if they were test cases, well, then I can use them both as requirements and as test cases, which means that I'm doing they're serving double duty. I don't have to write separate requirements and then separate test cases. I can use them for both. So these are ways of removing things that are not value. And that's again what's left must be of value. And then when we look at how we measure this and how we assess this, well, we have the usual story points when we plan our work. How big is a user story? But that's an effort. How much time do we think it's going to take for us to build this? Or how much effort is it going to take for us to build this? We can, of course, look at benefit points, which is an arbitrary measure where we basically look at, well, how happy will the customer be if they get this? Uh, and we can do that in roughly the same way as we do with story points. We could even probably use the same planning poker ideas in order to assign benefit points. That would give us an indication of how much more valuable one user story is over everything else. On the other hand, does it matter? As long as we have the prioritized list, we know that whatever is at the top of the backlog is the most valuable thing. And then it really doesn't matter if it's twice as important as or twice as valuable as the second item on the backlog, or 0.236 percent of benefit points, whatever, more valuable than the second item on the backlog. If it's at the top, it's the most important thing to work on right now. So probably the lean and agile people would say that playing around assigning benefit points and using these to prioritize and so on is probably a waste. It's probably something that doesn't contribute anything to the actual process of delivering software. It's messing around with requirements and messing around with user stories for the sake of doing that rather than working on the software. So we can, I think, is the long answer to your question, or the, I don't know, shorter. We can focus on what is value and what is valuable and so on, but it's more important to look at whatever means we use to decide what is the most valuable thing to work on right now. It's we don't need that level of granularity where we start measuring, well, that this is so good on this scale, but yay good on that scale, and so on, and then trying to do all sorts of mathematical calculations. It's valuable because the customer says so. It's simple enough for most practical needs, I would say. Was that a sufficient answer to your question? Good. And on that note, we can also at least mix in a bit with continuous deployment and continuous experimentation, which is because if we have continuous deployment, we also have the option of deploying um, deploying different versions of our software to different customers, especially with if we're using cloud computing, so that we don't have to release it to them and they have to install it or whatever. If they just use the normal web browser, log on and start using it, and some customers see one version of the product and other customers see another version of the product, then we can start looking at more fine grained what is value. If we don't have a clue what is the value, let's experiment. Let's see if version A is more valuable than version B. And what is valuable then? Well, again, that depends on the context. It might be that people click on it more, people interact with it more, people buy more on that website or whatever. People are happier when they have used it. How do we find that out? Well, we ask them afterwards. But it's a possibility with continuous deployment to do a bit of experimentation. Mind you, it's also expensive to do this experiment, so you would probably want to have a clear idea of what is it that we're looking for in this particular instance, what will be more valuable for us right now, and what do we think, what hypothesis do we have in terms of how do we get that. We could, I throw in big data here, but it's a big question mark afterwards. If we have collected a lot of telemetry about how people use our products, we could probably throw a few machine learning algorithms and so on at the data set and see if anything shows up that, well, people like that kind of product more than others. But I'm not, well, big data should be used for exploring, but I think that it's a bit overhyped that, well, let's just have a lot of data and then throw an algorithm at it and see what emerges. I like to have an idea of what I'm looking for first, but that's probably just me. So lean. I mentioned that we optimize the flow. We look at how to optimize the flow. The idea is that you pick things up from the backlog and you work with them and you push them forward or you pull them actually through this flow. And if you're able to do this in a streamlined fashion, well, you have a nice flow. If there are things that stop working, if you have bottlenecks, things that are get stuck, well, you don't have a flow, and then you need to have more resources piling up so that you solve this bottleneck, and then you can get this flow going again. This causes a few infrastructure challenges, so I'll spend some time talking about this because, well, my background is in architectures and so on, so I like that. The fact that we have each person is working on their own individual flow means that we put more requirements on the infrastructure that we're working on, so that we all have the same environment that we're working on. If I'm working on one feature, and then I do sort of, I modify the code, I might install some piece of software on my machine in order to measure things and so on, and then I'm done, I deploy that, and then I go back and I pick up the next item and I start working. And it works perfectly for me because I happen to install that piece of software. But that piece of software isn't common for everyone else. It's just something that I install in order to get the previous feature to work. Then I'm breaking this flow because no one else can get this to work. So what I would need to do is that I revert back to a baseline of my development environment. And then I build a feature and I deploy it. And then before I start my next round, I revert again back to this baseline. So I always have a reproducible environment that I can work on. And if I do need to introduce something in order to get things to work, I need to introduce it into this baseline so that everyone can benefit from this new tool that I had to install. So I want to ensure that I have a common work environment for development, one for testing and one for deployment. They should obviously be rather similar, but of course, if I do deployment, then I have this giant customer database and I don't want to use all of that, and I don't want to run tests on this live version, obviously. So I need to have a backup of it, and then I might scale it down a bit so I don't have to pay for as many cloud servers in order to be able to test my software. And I might scale it down even further so I can develop on my own local machine. But I want to have as similar as possible, so I know that if I do develop on my own machine and then I deploy it to my test servers, I shouldn't be surprised. Things should work the same way. And then when I do the deployment, things should again work in the same way, which means that I would avoid this work on my machine problem that you often hear. Well, we tried your code, we tried to launch it on the deployment servers, and it broke everything. And then the developer in question, well, shrugs his shoulders and says, well, it works on my machine. I don't know what you broke. So we want to have this common work environment. We want to have it reproducible. We want to have, and that reproducible means that it should be a one-click setup or running a bash script or something like that. It's not something that you have this long checklist of items. Install, well, first of all, format your hard drive, then install this software, then install this, then click on this, then do this, whatever. It should be one script. So that you are sure that you don't skip ahead or miss anything or anything like that. It should be easy to get started with a new iteration. That's where we get DevOps and why I mix that into Lean. Because the solution is that we make sure that we automate things as much as possible. Lean has something which they call 5S, which is basically 5 things all beginning with S, and I don't know, this is a Japanese practice, and how they managed to find 5 things beginning with the letter S in Japanese, I don't know, but I did. And these are fairly common, fairly um, self-explanatory things that we all do, even if we've never heard about Lean and software development or anything. We do these things in our everyday lives. It's just that they've managed to put words on it and describe a bit more what we are doing with it. So the first S is that we sort. We remove things that are not needed. We set things in order so that it's neat and tidy. We clean up and we tidy. We do shine. We tidy up our workspace so that we are ready to begin a new work process. We standardize so that we document whatever we do, and then we sustain it ever so often. We apply these standards again. So if I take an everyday example of this, let's go into the kitchen. Ever so often I will look in my drawers and I see that the fourth drawer from the top is full of everything that is rarely used. Some things I use there, but there are things there that well, why do we have this? Why? What is this even? So if I were to do sort, I would remove them. I would say that, well, if I don't know what it is, I'm probably not going to use it. So let's put that aside. Let's remove it. Every time I'm looking for a new spoon, or a ladle, I'm not going to be bothered with that the drawer gets stuck because of this item that I don't even know what it is. Remove things that are not needed. Everything that's left, make sure that I have some sort of system. I have ladles in the fourth drawer. I have everything for baking in the third drawer. I have knives and sharp items in the second drawer, and I have cutlery in the top drawer, and so on, so that I can easily find things. Where are my spices? Well, they're there. Where's the flour? Well, it's there. Things are where they're supposed to be. Shine. Well, if I'm making dinner, the first thing I do is to make sure that I have a workspace. I clean any dishes that are left standing. I wipe off the kitchen top so that I'm ready to start working on a new project, if you will. If I happen to follow a recipe and I plan on using this recipe regularly, I will make notes in the recipe with things that I do differently. So I will look at the recipe and I might see that, well, I can combine these two, or I don't have this ingredient, I don't like that ingredient, I'll replace it with this, and I'll make a note in the recipe so that the next time I'm making this dish, I know what I did last time so I can repeat my success. Well, I'm assuming it's a success because no one complains, at least. And the last bit is that I will ever so often go back and look in the drawers again. I will see that things haven't happened and things haven't moved around. I can still find the flour where it's supposed to be. I can find my baking stuff in the third drawer and so on. Things sometimes tend to get misplaced. Let's fix it up so that we actually can still work in this kitchen. So that's what I would do in the everyday life. I would do similar things in my tool shed. Before starting on a new craft project, I will make sure that I have everything I need and so on. So these practices are common for everything we do, but let's look at how we use them in software engineering. When we look at this source code, software code, this is a really big and hairy topic. It's the one I talked about earlier about how many are still using this feature. The technical depth things comes in here as well. Can I do something to remove some of that technical depth? But for my workplace, well, it's make sure that I have a way to regularly roll back my workplace to a steady state so that I can always make sure that I am working from the same basic setup as everyone else. Set in order, well, make sure that it's repeatable, make sure that I don't have to do things every time I reboot, for example. So if I go into the live environment and I do edits in the live environment, well, will they survive a reboot? Well, sometimes they might if I've edited some configuration script, but often they might not, because it's a matter of doing things in a running system. Problem then is the next time I deploy, I'm going to overwrite this, my changes in the live environment. So I need to go back and make sure that my deployment scripts are changed to reflect whatever changes I did in the live environment. Or actually, in the end, what I'm going to learn how to do is to never do any live changes at all. If I'm doing changes in my deployment scripts that I run towards a test server. And then if that works, I'm going to, next time I deploy my main product, that's when the changes will happen. Fix things in the repeatable configuration. Never fix things in the live running production system. And make sure that you have these startup scripts and these things. They should be one script away. I want a new server. Well, run this script. I want to have a clean database for testing. Well, run this script. I want to roll back the database or server or workplace or whatever to this initial state or to this test state or whatever. Well, there's a script for that. We can use make for it if you like, but we can use other scripts as well. It should be repeatable so that everyone can, by running this make test script, for example, everyone get the same result. It's not dependent on what you have on your machine. It's not depending on what you have done to your environment. This test script makes sure that you get the same starting point as everyone else. Get these test environments and get your development environments and so on as close to a deployment state as possible. Sometimes it's not possible. Your cloud provider only offers one version of the operating system, for example, whereas your local scripts might use another. You cannot have 500 terabytes of test data on your local machine and so on, so you might scale that down. And there might be confidentiality reasons and so on as well there, but have something which is as close as possible so that you know and you can be confident that if it works on your machine, it will work on the test machine, and if it works on the test machine, it will work in the deployment environment as well. Make sure that there are documentations. No one should wonder, I'm about to start a new iteration. How do I do that? Well, you go and ask John, he's done it before. No, absolutely not. You look in the documentation. This is what you do when you start a new iteration. This is the script that you run. Shouldn't be much more than that if you've done it properly, but it should be documented. How do I do a rollback? How do I deploy? All of these things should be documented. And you make sure that you document rules about who may touch the production service. Even if you have the possibility to change your deployment scripts, doesn't mean that you have the right to deploy towards the production service. Who may do that? When may they do that? During what times? During what conditions? And so on. This should be documented so that you don't have anyone can deploy to our production service at any time, and that might break things and so on. It should be a standardized process for it. And then sustain this. Well, continuous building, continuous testing. Make sure that the testing is in there as well, because the testing is important so that you are, you know that whatever you build will work. You get this confidence. If you have a working test suite, you have a confidence that my code works because the test suite wouldn't allow it not to work. That means that you can focus on building new feature, new code, working software, and be confident that if you break something, well, the test scripts will tell you. Tests, automated tests are to the semantics of the system that you build, what the compiler is for the syntax, if you will. So in terms of focusing on flow and what we can do on the infrastructure level, what we can do is we can make sure that we have the stable build and deployment environment, so that we are confident that we can change it when we need to, but it works. If it works for me, it will work for everyone else. We avoid some of the risky deployments where if people say that development environment, or if our development environment is more or less the same as the deployment environment, we know that if it works for me, it should work for everyone else. We avoid this, it works on my machine, well, because if it works on your machine, it should work for everyone else. So we avoid a lot of those problems. We ensure that we have repeatability there. So the bottom line with focusing on flow and this part is that if we make sure that we have proper support by the infrastructure, by our deployment script and so on, we can focus more on the flow, focus more on building working software, because the infrastructure will take care of the rest, and we get confidence that the infrastructure will take care of the rest. And DevOps obviously is just the next step from this, that we have working infrastructure means that we have DevOps very close at hand. I'll say a few bits about DevOps. This is really a very much a separate research topic, but it does tie in with Lean and Agile very much, because it is this focus on the flow, which means that we need to have working DevOps in place, and then that ties into Agile. That, well, then we need to talk about DevOps. So the classic way, the old way of doing deployment is that you have a separate team for deployment. We build software, and then once we're done, we'll hand it over to the deployment team, and they will make sure that it's installed at the customer site or whatever. With DevOps, what we're trying to say is that we are trying to bring that closer in, so that development and operations are done, if not by the same team, but at least intermixed, so that when we do get problems, we are that much closer to each other, so we can fix it that much easier. And that makes us more agile, because we can more quickly respond to things that are not working. We can, in the simplest case, we will simply mix that everyone is both a developer and an operations engineer. Everyone can do everything. We might have one person who is a developer and an operations engineer, but we mix it like that. We can. The next step is that we can have mixed teams, but we can have one person who is only doing operations. One person in the team is only responsible for making sure that the system is running as it should, and the rest are developing new things. But they are still there. We can still talk to them. We can still work with them. And the next step again is that we have some sort of bridge team. You have development and you have operations, and they are separate units, but we have someone who is a liaisons officer, if you will, working between them, so that we can, whenever we find something in operations, we can feed that back to development, and whenever we do something in development, we can feed that forward to the operations team. And this liaisons officer or bridge team is responsible for making sure that things run smoothly between these. One of the key things in DevOps is that the infrastructure is code. the deployment scripts, setups of new servers, and everything like that is just as much code as the features that we build. They have the same right to be configuration managed, for example. They have the same right to be reviewed in the same way as we would do with new developed code. We have architecture teams that are doing assessments of it, and so on and so forth. So infrastructure and the way we set up our system is just as important as the source code that we build, the software that we build. We really need to treat it as a first-class uh, citizen in our development efforts. DevOps, if you look at this, what the values there are, they are very much the same as for Agile: communication, collaboration, and integration, and so on. This is individuals and interactions over organizations, right? Make sure that we have a common culture, we automate things, we measure when we can, and so on. All of these things are very much hand in hand with Agile values. And that's probably why DevOps has come so quickly or so much in the recent years, because now we are more familiar with how to work with Agile software development, and then we realize that this makes sense also for all our support systems. If we start doing DevOps, we do run into a few cultural impacts. First one is trust. You have the operations team they have guarded the access rights to the production servers. Previously, they have been the guardians of everything that runs on the customer site. They quite often think rather lowly of us mere developers. You always bring stuff here that breaks, and we break it, and we are the ones working with the customers, and you come here with your shitty software and break things for them, and we have to go in and fix it. Um, so now with DevOps, they are going to have to work together with these lowly developers whose sole purpose in their life seem to be breaking things for them. They don't like that. This is the first thing that you're going to have to work with if you try to introduce DevOps into a company, is to make sure that everyone understands that this is good for everyone. It's eye-opening for the developers. Drink your own champagne. Or as an example, I once had the painful experience of installing an Oracle database, which at that time, this was many years back now, but at that time took somewhere in the order of 30 something hours to install. And this entire installation process was full of the questions you had to answer throughout the process. So you would answer a few questions, and it would chew along for a few hours, and then it would ask a few more questions, and then would chew along for a few hours, and then so throughout this entire 30-hour operation, you would have to be there, babysit the machine, answer questions ever so often. Then it would be working for a while, and then we'd ask a new question. So in the end, we had 3 people working shifts to install this Oracle database. If you had been forced to do that as developers, you would quickly realize that we can ask all these questions first, and then we can let the machine chew unsupervised for 30 hours. So drinking your own champagne means that you figure out where things aren't working as optimal as possible for the deployment teams. You become aware of the problems with deploying your own software. You become aware of that there are differences in the tool stack, for example. I've got this version of our programming language installed, and that other person has this other version, and they are not compatible, and so on. So you become aware of these things. We add a few responsibilities to the development or DevOps team. You have build masters and so on, and that's somewhat good, of course, but it's not only good. Having mixed responsibilities often means that you focus on one and then you try to neglect the other one because, well, it sounds like work, so let's not focus too much on that. Again, I started out with Conway's law. If you have focus on one thing than other things as someone else's job. Having admin rights on the production service might be good because you can collect statistics, which is good. You can figure out how is our product being used, where are the bottlenecks, are there any performance issues, whatever, and so on. You could use it for debugging as well. If something is not working as properly, you can trace it and so on. I would discourage that though, because it means that it's so easy when you're debugging things on a server that you see, all right, here's the problem, so you fix it. And then, problem solved. I fixed it. I debugged it and I fixed it. Until next time you deploy and you overwrite that fix. Then it's much better. And you don't know if that fix was the right one either. That's not a problem. You think you fix it. And in fact, you just made things worse. And now you had a small problem for one customer, and now your entire deployment doesn't work anymore because you tried to fix things in the live environment. So debugging is it's not a good idea because it's so easy to accidentally break things on the production service. Then it's better to start up your own version of the system. Again, you have one-click deployment scripts for that. Reproduce whatever problem that you had. If you cannot reproduce it, well, then that's another problem in itself. But reproduce whatever problem they were experiencing. Debug it on your own development environment. Introduce a fix through the proper channels, through configuration management, and so on. Deploy it to a test service, make sure that it works, and then eventually it's going to be deployed to the customers. Right, so a quick summary, or actually not a summary, things that I think could be interesting to look further into in Agile and Lean. One of them is, well, there are a lot of Agile methods being marketed at least. So which of them are actually used? And to what extent? When people say we use Scrum, do they use all of Scrum or do they use parts of Scrum? I would guess that they do use parts of Scrum, but what particular practices then are being used? Kanban and Scrum, they're not two sides or mutually exclusive. You can use them together, but since people talk about, well, Kanban is one thing and Scrum is one thing, well, which one is better then? Which is more productive? And what do you mean by productive? Global Agile, when half your development team, not a different Agile team, but half your development team sits somewhere else, can you work properly then? What are the challenges there? Test frameworks for development for DevOps, this infrastructure as code idea. So how can we test our deployment and development environments, deployment scripts? How do we test them? They should be tested. They should be treated as code, but how do we do that? Well, today what we do is that we run them and we see that, oh, I got a machine and I got everything installed. Can I automate this in some way? Different frameworks for continuous deployment and experimentation and so on. There are a couple of them, and evaluating them from different perspectives would be interesting. Tests, you build your software and you have this wonderful software architecture for the software that you build, and then you have a flat structure of 500,000 tests that run on your architecture. Why isn't there an architecture for your tests and your test suite? And what would be a good software architecture for automated tests? Are they different? Do you have architectural patterns and design patterns for test suites? That would be interesting to look into as well. And sustainable Agile, I'm guessing that at a certain point, when you've developed your product over a number of years or across a certain number of teams, or a combination of the two, you start to lose the organizational memory, or the team memory is no longer sufficient to figure out what's happened to this product. So you need to start to add more documentation. You can no longer rely on that the teams communicate with each other. You need to have some form of documentation in place for them to be able to figure out what happened 10 years ago, communicating with the team 10 years from now with the help of documentation. So where are those breaking points? And what then is the right amount of documentation in order to make sure that you give sufficient information for your future self, but not more. So that was what I had to say today about Lean and Agile. I'm going to stop the recording now.